Hello, everyone. Welcome to our next ESIP IT&I webinar. The date is currently August 14th. This is our first webinar after the July ESIP meeting in Seattle, which was a great success. Myself and Keenan chaired a session, and so what I'd like to do is first share some takeaways and some interesting discussions just about how you can run Jupyter notebooks in many different ways, which was showcased during the session. And then Keenan is going to show some work that he did at another worker with Project Pythia after that. So let me go ahead and share my screen. I've got a slide deck here. Okay. All right, so again, this was from our session that we ran at the 2025 ESIP meeting in Seattle just a few weeks ago. We had 3 different speakers. I'll get into that in a little bit. But something that was really unique about the session that personally I have not found this amount of variety in terms of running Jupyter notebooks specifically is that there are a lot of different options to run them. So just as a little bit of background, in our session, all of us, were involved in geospatial sciences and data science specifically, and a very popular tool to use with that sort of data is Jupyter Notebooks, which uses Python. You can also use Julia. A lot of other folks use R. But Jupyter Notebooks combine the benefit of Markdown, which is where you can have readable text and images, links as well, alongside running Python code. And so what you can do is run these notebooks in different ways because they have to connect to a kernel. And sometimes you need more or less compute space. But there are a really wide variety of ways to set these Jupyter notebooks to set these Jupyter notebooks up. None of them are necessarily the best way to do it. And so there are several considerations. The first one is, are there highly specific packages or a custom environment? So what that means is that typically when you're running in Python, sometimes you have libraries that have lots and lots of other dependencies on other libraries. And so it's best to isolate those environments. With some of these ways of running Jupyter notebooks and sharing them, you can configure them, or you can have kind of minimal configuration or none at all. Another consideration is your storage. If you're working in that Jupyter notebook and you are actively saving files, or you want to edit that Jupyter notebook, do you want that shared in the shared space that's being hosted somewhere? Do you want it stored locally on the user's machine? Or do you want it to just be completely ephemeral because there is no need to do that? Another consideration is compute space, and this also has to do with cost. Some of these platforms run in the cloud. Some of them have free tiers with various ranges that you may or may not encounter in terms of hitting some of those paid tiers based on the application that you have. And then the last option, which is kind of related to that, is what is the goal of your notebook in terms of how long do you need it to go for, and really how far do you need it to go? So maybe you're showing a quick demo like we did at our session for a few of our notebooks, where we're just running code demonstrating how a library works. Or do you need to turn that into a long-term space of analysis? So maybe you're in a classroom environment where you need users to be able to come back to be able to access their data afterwards. So we're not going to be talking about how to set all these things up, but I think it's a good discussion because personally, I work over in the user needs team, and I make a lot of different documentation, particularly around Jupyter notebooks. And so there's always questions about what is the best option for us. And so that's, I think, a good discussion that we can start today at this meeting. So I want to talk about some of the environments that we saw used. Actually, I think I might be a little bit out of order in my slides. Yes, here we are. Okay, I think I accidentally skipped the first slide, which was the actual titles from the session that we had. So Keenan, who's in the call today, presented Tensors and Back Again, XBatcher for filtering, resampling, and assembling model output. You can see the Google Colab logo to the right of it. That's what he used. And that was really, really a great session because he was able to get GPU support for running some deep learning. What I did was I presented efficient hierarchical data access patterns using X-ray data trees. That was some open source work by some colleagues of mine, and they allowed me to present a demo of that. And I used something called Jupyter Lite, which is basically a WebAssembly environment that is entirely centralized in your browser, in your internet browser on your machine. And as a result, you don't need cloud. And then our third speaker, Rajat Shind, had a talk on converting LiDAR files into cloud optimized point clouds. And he had a binder hub configuration set up. And so you can see those three different logos here. Talking about those three different environments, this is just a table that very briefly surface level compares immediately their functionality and also some of their cost and levels of configuration. Google Colab is free to use. There is a free tier that restricts you to the amount of time that the runtime can be active for. That also changes based on if you want GPU support or not. But you can open up a Colab notebook really at any point in time. If you run it, as long as it's underneath those runtime restrictions, you're not going to have any interruptions. But even if you do run into those interruptions, you can simply restart the kernel and run it again. To configure them, you can actually use, there are some libraries that can be used to install custom Anaconda libraries within Google Colab, but you will need to run those every time you run it. You can fortunately just use Conda installs or pip installs if you needed to install one or two libraries. It has full access to the external internet. And then lastly, is there storage persistence? There is, but it requires a Google Drive account. So what you can do is you can share a Colab notebook that is kind of hosted just on the on kind of Google's side of things. It has a ephemeral storage area that you can use, let's say for maybe creating a plot, generating it, saving it to your local machine. But that's going to be on your local directory. If you want it linked to a cloud directory, or if you want it to reference other notebooks in the Google Cloud, you would typically connect it to a Google Drive account. You can also connect these to external, let's say, cloud storage spaces if you have, let's say, an S3 bucket set up in AWS. And then you can also save the Colab notebook to GitHub. And there's actually ways that you can run a GitHub hosted notebook on Colab. So those are kind of the three things there for Colab. Moving on to Jupyter Lite. So Jupyter Lite is relatively newer than Google Colab. It is completely free to use. It's completely open source. The way that you configure it is by basically making a copy of something called a GitHub template on GitHub that contains all of the workflows and actions that are used to actually compile and deploy the Jupyter Lite server. And that's typically hosted using GitHub Pages, which is also free. There's a free tier for that. As a result, when I put in the configurable box there a sort of, that's because it depends on what you're trying to configure. So for example, being able to configure the Jupyter Lite server to actually be deployed to a page, a web host, and then to be able to just open it anywhere, you have full control over that. You have full control over files that you might want to include. Those you would use GitHub to host those. But in terms of being able to install custom environments, you're limited. And that's because Jupyter Lite actually runs entirely in your internet browser and using something called WebAssembly. So as a result, some libraries work, some don't. And that's also because it doesn't really connect to the external internet. And the same thing goes with that storage persistence for users category. It's a sort of, because it has some access to your local storage, you can also drag and drop files into the interface that it has, but those are pretty much ephemeral because it's using a either a virtualized storage space or it's just sitting in your browser cache. And typically that gets cleared every time you restart a browser session. The third option there is Binder Hub. Binder Hub is also a community open source tool, but what they allow for is configuring a Jupyter Hub, which is basically the kind of the vanilla interface of um, interacting with Jupyter notebooks in a shared compute space. They actually give some free compute space for you to host a notebook and share it with folks. As a result, that allows you to have the full suite of Anaconda and pip. If you have any sort of custom libraries or environments that you wanted to, if you want to deploy, you have complete control over that. But in terms of free to use, there is limited compute space if you don't want to host it yourself or deploy it on containers yourself. And that's because it uses community-based funding. So there could be long-term interruptions potentially if you're using a binder hub for any sort of long-term analysis. The storage persistence for users, I also put a sort of, and that's also because you would need to configure a storage space similarly to if you were to create a Jupyter Hub server anywhere else. So in AWS, you might need to connect it to an EBS block store. If you're running the Jupyter Hub locally, you can have it running from your directory. It's very customizable, but this is kind of just an overview of what it is. And even here, there's a lot of variability as to not only what these platforms can do to run the Jupyter notebooks, but also the libraries that they use and the ability to interact with different tools. So there are definitely several levels of interoperability differences. Getting into a little bit more details about each of these, with Google Colab, you can actually use something called GitHub to Colab to run any GitHub notebook on the fly. You can see that on the right side there, I have a screenshot of what it looks like when you select the runtime. And there's all these different options to be able to manage your sessions or connect to a hosted runtime. For Keenan's notebook, he actually used the T4 GPU, and there is a access limited to 3 hours before the kernel restarts for the free tier. But that's really great because that means that you can run things like deep learning analysis really anywhere that you have an internet connection. You don't have to have that hardware yourself, and you don't have to set it up for yourself. But of course, you can't set it up, and you don't have control. So there really is a limited amount of things that you can configure in terms of the compute space that the Jupyter Notebook runs in. Another thing to consider is that Google is a private company. Some organizations might not have access to Google. Some organizations might make you use a different cloud platform. And so that is something to keep in mind. For Jupyter Lite, now Jupyter Lite looks just like a regular Jupyter Hub server. But this actually uses those GitHub templates for configuring, and then it uses a kernel, which can either be from the Jupyter Lite community, or it can be from kind of the open source community that looks to expand its abilities. The one that is really heavily supported and tested with a curated set of libraries that are known to work with Jupyter Lite is specifically the pyodide kernel. So the pyodide kernel allows you to install libraries like Cartopy, Matplotlib, Xarray, and those are libraries that are coming from the pyodide kernel specifically. So it's not recommended to use, let's say, a pyodide kernel outside of a Jupyter Lite environment. What that allows you to do is use those libraries in these notebooks. But the biggest caveat to using Jupyter Lite notebooks right now is that there is zero internet access and very minimal compute. Because it's running in your browser session, your performance may be limited to your browser settings. Some browsers give you the ability to turn on hardware acceleration or turn it off. Some browsers are more or less friendly to Jupyter Lite environments. But the thing that they all have in common is that the internet access is very, very minimal, if non-existent. And that's mostly due to security reasons. For example, I would love to get a Jupyter Light notebook going that actively creates, let's say, an opened app subset, and then returns it using something simple like requests. But because of things like cross-origin resource sharing, not only can you not authenticate with Earth Data login servers, but you can't really talk to other browser tabs, and there's a really limited amount of things you can do. So it is intended with the best purposes for security, to make it really lightweight. You can open Jupyter Light notebooks anywhere. You can open them on your phone. It doesn't spin anything up in the cloud. You can run it completely locally. You could even put your own custom measurements into a script and run a script. But that is a really big caveat with that. And so there's no persistent cloud storage for this, but again, you can host those files that you want served through the Jupyter Light server in GitHub. And that uses the same Jupyter Lab UI, which can be seen either in your local environment or in Binder Hub or in really even the OpenScapes 2i2c hub. The only difference is that you'll notice some tabs are missing. The last option, which is not really the last option, but it's one of many options, the last of which we will cover today, is Binder Hub. So it does require some experienced setup to be able to deploy Binder Hub. You can manage it through GitHub, but it really helps to have knowledge of Kubernetes containers and how to register them. So basically what that means is that you don't have to necessarily figure out how to put together a cloud compute instance and have to go through training and setup and cost comparisons to be able to figure that out. You can simply just create the container that would run in those cloud platforms, and then you can just register them on some free tier instances, which is really useful, especially for quick demos. The only problem with that is that really leads you to a limited amount of time that you could use them consistently, especially if you want to spin up a notebook right away, have instant access to it. If you were to deploy your own Jupyter Hub server in your own cloud instance, you can have control over that in terms of load balancing or really any other ways that you can reduce compute costs yourself. But in this case, it is a community project that is running it. And so you are using community funds for that, which can be quite useful. The only difference is that it always helps to be courteous in terms of that, especially if any long-term analysis is there. And of course, this is also Jupyter Hub as well. So the recordings for all of these notebooks are in the ESIP, the Sketch page, which is linked there. You can see all of the links to our demos and also the full explanations of what they do. It was really great to be able to have all three of those back to back to back, and to be able to have that audience participation, especially with things like the Jupyter Light notebook. We had an attendee try to run it off of his iPhone, and he had some issues with that. But that's something I had not tried because I don't have an iPhone. And so I thought that was great to try out. And so I think with that being said, I don't know how many other folks have joined since I started talking, but I think before we move to Keenan's talk, we've got a few minutes just to kind of open up a discussion about this, or what tools do you prefer for your particular analysis? And so it looks like it is the four of us. Keenan, what was a reason, or what were some reasons that you decided to use Colab for your demo?
Yeah, I think the main reason was like GPU access because we were fitting like although it was a really small deep learning model, I really wanted like for that demo to be like fast. Like I didn't want it to just be like, all right, hit this cell, now we're all gonna sit here for 10 minutes to like wait for a bar to fill up. And so on the GPU, I was able to verify like the night before that the like tiny model we were training would take like 30 seconds. And so that wasn't too bad at all. I think another component is that I had some external Python files that I want to be able to like import from in the notebook. And the best way I found to do that was to like git pull the repository, which meant that I needed access to Git from sort of the notebook environment. And I don't think Colab is necessarily the best way to do that, but it's the first thing I tried and it worked. So that's really why I ended up using it. I didn't really do like a full survey of all the tools we've discussed here before making that choice. But yeah, that's where that came from.
Yeah, that's always what I run into is that it's, you know, the KISS principle is definitely in there to keep it simple. And I really do appreciate how you can just convert any GitHub hosted notebook to run with Colab and test it out, see if it works for you, see if it works in all these different settings. So we didn't really have any like heavy audience participation with our demos, especially with like entering code and configuring login files and things like that. I think we had some of that, but we didn't really run into any issues with that, which I think is also a testament to how far those have come along, especially in terms of Earth data login and things like that. Patrick Clemens says, I haven't used any of these cloud options more than cursory, so this was interesting. I just pull up Jupyter Hub on a local-ish machine, sometimes on a VM. Yeah, and when you do that, Patrick, if you don't mind me asking, and certainly if you don't mind unmuting yourself, do you use Binder to configure those for the VM, or do you simply just run the Jupyter Notebook command from within that VM to start it?
No, I just run it from the terminal prompt, Jupyter. I create a Python instance or Python environment, install Jupyter into it, IPy and go from there. Yeah.
Yeah, yeah, and that's what I really appreciate about the interoperability of Jupyter Notebooks is that you can really run them anywhere, and that's also because you can connect it to runtimes that are either local or external. And personally, I actually I start a local kernel, and then I use that with the online version of VS Code for whenever I make changes to documentation. That always helps me out because then I can manage my own files locally, and then I can make it so that I'm not having to constantly do Git pulls and things like that.
Yeah, I was just going to say, actually, we've been using VS Code pretty exclusively. I mean, we used to use Jupyter Hub at, up pops Firefox, but over the last year, we've pretty much transitioned exclusively to VS Code, doing this very similar thing. Yeah.
Yeah. Yeah, and then the only I guess kind of thing there again is the Git tracking with stuff. And so for me personally, it's nice to open up a browser in a branch in GitHub that I'm working on, and then I can just change the .com portion to .dev, and then it opens that online implementation of it. And for me, that's just a big time saver. Yeah. And actually, I would like to share with just a couple minutes left one other thing that I literally found out about last night, which is it's a tool called Obsidian. And so I will share my screen again. I don't know if any of you have heard about this. It's been around for a while. It's been around for a few years, but it's basically a note-taking app that uses Markdown, and you can tag notes to each other. And then it gives you a knowledge graph of all of your notes, which is amazing. And what you can do is use plugins with it. And these plugins are incredible. I've seen plugins that people use it for managing Dungeons and Dragons campaigns. They have dice rollers in them. But what's really exciting is that you can actually use Jupyter Notebooks with them. And so there is this plugin here called JupyMD, which is hosted on GitHub. But this is something that I want to try because you can convert a Jupyter Notebook into a Markdown file, and then you can basically tag different parts of it. And the tagging is what I'm really interested in, because there are a lot of ways of, we have a lot of notebooks that I work on where you might access one data set with OpenDAP, and then you might access another with S3. But what I want to do is be able to point out, here's the thing that you will do for all of those platforms, and here are the things that make it different. And I would really love to be able to tag entire cells with this. But this is something I just found out the other night about. And the other cool thing about Obsidian is that it uses your local file system, which means that you can use GitHub to manage your Markdown files, for example. The only thing with it is that it has some pricing. Let's say if you want to sync your devices together, that does require some and you don't want to have to configure, for example, GitHub, or you don't want to have to configure some sort of tool that syncs those files. It'll just do it. There's also a couple of different pricing tiers for storage space for cloud storage, but this is hopefully a fourth option, because it was a really big goal of mine to get that Jupyter Lite going, and to do something new like this for another session or something like that is something else that I think would be kind of exciting. So let me go. Oh, and you have been using Obsidian. That's great. Yeah. Have you liked it? Do you use it for work or for other stuff? Or
Yeah, I actually have a what do they call it? A vault for work, a vault for home. I just use it as a note taker. I've installed a couple of the plugins in there, but I didn't know you could do Jupyter in it. That's pretty cool.
yeah, it looks like it's relatively recent too. I just don't know if you can run the notebook from within it. I think you can run the notebook and then convert it to Markdown and then just note take on the Markdown of it. But yeah, I'm curious to learn more about that.
Hey, Chris, have you played around with the GitHub code spaces?
The code spaces, yes. I don't use those a lot though, because I've got some restrictions at work.
Oh, yeah.
So yeah, and personally, like I said, I'm running environments that they don't require a lot of computation, but they require really specific versions of some libraries due to authentication. And so I'll just do
Mhm.
the port forwarding, the local runtime. But code spaces, I think, is another thing that we could definitely show, especially if someone's able to use it for a demo. I mean, that's basically Microsoft's version of Colab or some of those other things. So
Mhm. Yeah, and you can configure it to use, from what I have seen so far anyway, Jupyter Lab or VS Code. The thing that comes to mind from my previous experience is I don't know um, how easy or if it's possible to define which, say, cloud region you're operating within. That'd definitely be an issue with some of the, I mean, doing direct access in NASA space. But yeah, it's actually I use it here and there, and then also the .dev in GitHub is awesome. I love it. But yeah.
yeah, I've actually used I've used code spaces for some Earth access features as well, and that was a while ago. But I did that because you can use the I can't remember what library it's called, but it's one of those libraries that helps you create a virtual environment for testing different implementations. And I was able to contain it within a code space, and that was really nice, because then I didn't have to try to set all of that stuff up on my machine, and have to configure a new environment and all that stuff. But yeah, I'm not that familiar with Azure. and I'm not that familiar with how their cloud storage or compute works compared to AWS. So, and since a lot of NASA stuff is in AWS, naturally, I just know more about that. So, yeah. Well, I think with that being said, Keenan, I can hand it over to you, and looks like we're pretty good on time so far.
Yeah, sure. We can go for it. Yeah, so I guess a little bit of context before I get into this is, like Chris mentioned, the talk I presented at the ESIP meeting was a tutorial on some new additions that I've contributed to XBatcher, which is a Python package for linking X-array objects with deep learning models. This is, of course, a bit of a challenge because X-array, we can think of it as just labeled arrays. And then when we take pieces of that data and feed it into a model, with pretty much every deep learning workflow, you lose all the metadata that comes with X-ray, which is a bit of a loss. It also makes it challenging where if you have a deep learning model that is changing the dimensions of the input data in some way, say we're like cropping what the initial data was, or we're adding a channel axis, or we're adding like a class probability dimension, or all those different things. We would like to be able to make those changes, but still retain all the rich metadata that came with the original X-ray object. I'm not just going to like rehash that demo. The recording is out there if you want to go look at it. But what I am going to tell you about is a bit of a report back from the Project Pythia cook-off that I attended last week, where we turned that demo into a more fully fledged tutorial that is much more interactive and I think a lot clearer kind of at our motivation for that project. And yeah, so I'm going to share a little bit just about that. We can start just like for context. Project Pythia has emerged as they're kind of the education arm of Pangeo. I think that's how they would describe, or how folks there would describe themselves. So the idea is that they make a lot of educational materials for scientists doing research with the Python geospatial stack. They have a kind of foundations, which is a series of notebooks that themselves constitute like a really solid like intro textbook on doing geoscience with Python. But then in addition to that, they have all of these things called cookbooks, which are self-contained, well-documented, fully executable series of Jupyter notebooks. So you can have like more than one notebook in your cookbook that focus on a domain-specific problem. And so here I'm just at like cookbooks.projectpythia.org, and I'm going to hide the Zoom controls so that so that I'm sure that you all can see everything I'm showing. There we go. And you can see that a lot of these focus on specific data sets. Like here, there's one on CMIP6 or radar or Landsat or Kerchunk, so on and so forth. And some time ago, there was this cookbook which was made, which is called XBatcher for Machine Learning Part 1. This is from a few years ago. And these get made usually at cook-offs, which are like week-long hackathons where instead of hacking towards a particular scientific product or some other general project, you're hacking towards building a cookbook. This one was never fully finished. I don't think. You can see like there's a part 1, but there's not like a part 2 anywhere in here. And if we look into this, I found this when I was first trying to like learn XBatcher and like get better at this, is that if we actually jump into the part that is supposed to be like showing us how XBatcher works, you'll notice, and I have it in here. Well, first they hit an error, which is unfortunate because some data disappeared or some data they were using in this tutorial is no longer available. So we keep going, we keep going, we keep going. You'll notice that they actually comment out the part that's using XBatcher, and then they do this more manual kind of hacky solution to do the same thing. And in case you're not familiar with XBatcher, the whole point of that library is that you start with X-array objects and you like sort of clip out little pieces of the data that you then pass to a model. So say you have like a huge Landsat image, it's like, I don't know, 4,000 by 4,000 pixels, and you want to make little 64 by 64 chips that you pass into a CNN. XBatcher does that. So the current state of the tutorial on this is, it could be better. We could show more of like what this API lets us do. And then there's some additional functions that I've since proposed for Xpatcher that I think make the developer experience a little bit more fluid. So last week, I worked together with Nabin Kalauni, who's at the University of Arizona. He's also a graduate student. Super great guy. It was awesome working with him. And we made our own cookbook that shows an end-to-end workflow with Xpatcher, as well, and shows some sort of new functionality with it. You'll notice that this cookbook is actually live. Like you can go to this link if you want right now. In fact, I'll just like drop it in the chat for posterity there. But we don't have it fully published yet. There's like a little bit more I want to do before we have that like version of record out in the gallery. But this is here. The execution, or sorry, if I come down to sort of this example with topography data, which is the actual, this is the tutorial that I showed at ESIP. And again, I'm not going to like fly through it, but the idea is that we train an autoencoder. So this is a neural network that starts with a little patch of terrain data. It compresses it to a latent vector that is about 95% smaller than the original array. And then it tries to go from that compressed latent space to reconstruct the original model. You'll notice here that this model is actually doing like a really good job at that, which is really, really cool to me, that you can compress a little piece of data by 95% and still get it back out with this approach. But we have some stuff in here, like, for example, we have, oh, actually, this version is not updated with some changes that I've made locally, but suffice to say, we show an example here where we take these, and of course the progress bars are like imputing a ton of output in this, so it's hard to scroll. What we're doing is we're taking the 64 by 64 patch. This gets compressed to a 64 element vector inside the encoder. And so you can think of that as collapsing down both of the X and Y dimensions to one unit. My advisor sent me a message. Thank you, Monica. And then adding a 64 element channel axis. So we're going from 64 by 64 to what would it be? 1 by 1 by 32. That's a fairly complex transformation of the input data. But what we show is that with a very simple function, with this predict on array API, and there's some details here with what these arguments mean. That's all like in this demo. I'm not going to go into detail on that. But we can take that and get the original, a object resembling the original X-ray data set back out. So you'll notice here that the pixels here are looking a fair amount more coarse than they do in the original DEM, which I'm not sure I showed, but there it is. You can see that those pixels are a lot finer. And so despite modifying the resolution of the input data and altering its dimensions, we can reassemble this back together into an X-ray object with resampled coordinates that we can do all this, clean, very fluid, easy to use X-ray API with, which is awesome. We show an example here of like, these are all the terrain patches that are, have high similarity with Mount Olympus, Washington. Unsurprisingly, all the mountains are really similar to like the really tall mountain in this part of the world. So like, that's not very surprising. But yeah, the goal of this was to show an example of the new stuff that we want to add into Xpatcher. So very, very soon, you should be able to see this cookbook in the Pythia gallery. And then myself and Nabin, we're also going to submit a PR to Xpatcher to add some of this functionality to it. So yeah, that is a super whirlwind update on the talk I presented at the ESIP meeting, and I'm happy to take any questions on it. Thank you all for listening.
I can get it started here if nobody else has any burning questions. But I really like how you guys have, been able to, in such a quick amount of time, you've been able to make this demo notebook, show it at the conference, get it published in this open source, project through Pythia, and then you'll get that PR going. What have you run into in terms of any sort of caveats or barriers that helps you do that? Are you in contact with someone for being able to fulfill that PR, or?
Yeah, I think it's like, I mean, I think one of the bigger caveats we ran into, or at least what I ran into, this is the first time I've like really gotten involved with like an open source project, so this is all like a very new experience for me. But it was interesting thinking about the specific use case or the specific problem that I'm trying to solve myself, and that's very different from trying to solve like a general problem that many people have. Like myself and Nabin, when we were working on this, I started with some like first draft super hacky code that I had made to solve my specific problem. And the more we looked at it, the more we were like, oh, there's that corner case. Oh, and there's that corner case that we need to account for, which was difficult, but fortunately we were able to work through it. And yeah, that was a really interesting experience of like developing for a community is very different from developing for oneself. And then as far as like actually getting these PRs merged and whatnot, I don't know yet whether this kind of feature is something that the Expatcher folks or like the sort of core maintainers want to include in the overall design philosophy. This might be like feature creep or just not something that they really want to maintain, which would be fine. If that's the case, then this could just be on like a separate fork or whatever, and people would still be able to use it, and we could reference that fork in this cookbook and just say like, if you want this, here's a little offshoot. You just have to modify your git install a little bit. Yeah, I think that answers your question.
Yeah. Yeah, I've been running into that in terms of like picking up older libraries that are still used that may have incompatibilities with hardware. And yeah, but still, just being able to get that contribution out there and being able to, even if it's not merged in the main, as long as we can get it out there of how to install it and run it, then I mean that's still awesome. So yeah, that's great work.
Thank you.
All right. Does anybody else have any other questions or comments? Aaron, do you have any announcements or anything, or no?
I got a couple. I don't know if they need to be recorded necessarily.
Okay.
Okay, I can stop the recording if you want.
Yeah,
Okay.
let me just, I can if they want, but the July meetings highlight, I think you both are involved in that, is Monday, August 25th. That's open to all for anybody who wants to attend that. And then ESIP, of course, is looking for a new executive director. That position is available from our website. So feel free to pass that information along or apply yourself. Other than that, I think that's it.
Awesome. Yeah, I'm looking forward to that talk on the 25th. And then if anybody else has any other suggestions for any speakers at any future webinars, just feel free to reach out to some of the emails that are put in the IT&I committee pages, and we will try to get those in. All right. Well, I think we
Awesome.
can stop the recording.